Hello everyone, my name is Ashley Goodnight and this is my Lab 3 presentation. First, let's move to the introduction. The purpose of this lab is to calculate the net force, both parallel and perpendicular, and the unknown mass of a black hole given an orbiting star's mass and position data over one revolution. We care about the conclusions and results of this lab in order to apply our knowledge of the main physics principles, such as Newton's second law and Newton's law of gravitation, and in order to gain experience taking real observed motion data and finding the forces behind it. In this lab, I was able to model and find the forces and mass of the black hole. Here's a more in-depth summary of my results. In GlowScript, I successfully created a model of the star orbiting around the black hole, complete with arrows representing the net force, force parallel, and force perpendicular to the star's velocity. My program output final velocities for the net force and approximated mass of the black hole. Let's take a look at that GlowScript code. Here we can see that I used my tech email to create a unique set of values for the black hole. Then I added in the gravitational constant and the conditions of the star's mass and a delta t of 1 day's equivalent value in seconds. Later in the code, I made some more modifications, as seen here, to update the momentum and solve for the net force. I also made some edits in order to find the components of the net force and calculate the mass of the black hole. This last snippet of my GlowScript code controls the force arrows, which we'll see and discuss later in the lab. I want to highlight the specific physics concepts I used when creating my code. First, I used two different forms of the momentum principle. I used the first equation, P equals mv, to update my momentum. Then I used the second equation, dp dt equals fnet, in order to solve for the net force of the system. Lastly, I rearranged Newton's law of gravitation as shown below in order to solve for the mass of the black hole. I also wanted to explain some of the VPython functions I used in my GlowScript. First, I used the norm function in order to find the unit vector. Then I used the mag function in order to find the magnitude of a given vector, which followed by a 2 just squares the value. As mentioned earlier, I edited the values for the arrow scale. The end value I chose, 7.5 times 10 raised to the power of negative 18, was selected after guessing and checking what size of arrows could fit for my model. With the code all set, let's see what it produced. Here is the video of my GlowScript program running. As you can see, the yellow star makes an entire orbit around the black hole at the origin. To clarify, the purple arrow is the force parallel, the blue arrow is the force perpendicular, and the orange arrow is the net force. Now I will cover the analysis questions. What does it mean? In comparing the momentum and net force, I used the momentum principle to relate them. Starting from the equation P equals F times delta T, we can integrate both sides, leaving dp dt equals Fnet. This proves that the rate of change of momentum is equivalent to the net force, which holds true for their parallel and perpendicular components. What if we were to remove our original black hole and replace it with another black hole, yet the motion of our star remained the same? Would we be able to determine the mass of the new black hole? Yes, actually, we would. Since the motion is the same, values like position, velocity, momentum, and gravitational force would all be the same. In turn, we know that the mass of this new black hole is the same as the original mass. With that, I am concluding my presentation. Thank you everyone for watching.